Okay, this is one of the difficult problems that is asked every year in trigonometry sessions. Hexagon ABCDEF is inscribed in a circle with center M and radius capital R. These segments AB, CD and EF are such that their length is equal to R. Points I, J, K, I, J and K are midpoints of BC, DE and FA respectively, then we are supposed to prove IJK triangle is equilateral. Now, this is relatively high level of difficulty problem. However, the interesting part of this problem is that it can be solved using trigonometry and complex numbers. Somebody may solve it using pure geometry, but I am not aware of the solution of pure geometry. We solve this problem in two ways. One is trigonometry and second is complex numbers. So today I am giving you the solution of trigonometry. Now this angle is going to be 60 because this is equilateral triangle. MAB is equilateral. So the included angle is going to be 60 here. And then these are isosceles triangles, MAF, MBC and MDE. And MK, MI and MJ are going to be altitudes. Therefore, I have taken two sample angles, or I have indicated these half angles, half vertex angles of isosceles triangle X, Y and Z. Therefore, we directly get this relation X plus Y plus Z is equal to 90, because 60 plus 60 plus 60 is out of 360 is taken by three equilateral triangles. So remaining 180 will be taken by 2x plus 2y plus 2z, and therefore x plus y plus z is 90. Therefore, angle IMK is going to be x plus y plus 60, which we can consider as 150 minus z, because if we use these two relations, we get this angle like this. Distance MK is going to be r times cos y, and MI is going to be r times cos x. Right, so these are the three things which we require for finding out IK, length IK. The strategy is just to find out one of the lengths of this isosceles triangle and equilateral triangle, and show that it is symmetric with respect to XYZ. And if that symmetry is achieved, that means if we find out the length JI or JK, they are also going to be looking alike, and therefore it is going to be equilateral triangle. So the efforts need to be done to find out one of the lengths. I am choosing IK square, and if I could produce symmetry out of this, then I can say that IJ square and KJ square also will look alike, and therefore it is equilateral. So it is simple calculation henceforth. So this is a cosine rule which I have applied for finding out IK square, and angle, included angle, I have taken 150 minus Z. So now let us start working on this. Is equal to R square, and inside bracket I would like to write 1 plus cos 2y upon 2 plus 1 plus cos 2x upon 2 minus, this is this bracket, minus 2r square cos x cos y, and here itself I would like to expand this, which is cos 150 cos z minus plus sin 150 sin z, right? That is where makes it r square common, 1/2 plus 1/2 plus r square by 2 inside bracket cos 2x plus cos 2y can be, identity can be used. So 2 cos plus cos is 2 cos x plus y, 2x plus 2y by 2, so x plus y cos x minus y, which is 2x minus 2y upon 2. So this is what is our first term, minus, now let us evaluate this directly. Cos 150 is minus root 3 by 2, so this is plus root 3 times r square cos x, cos y, cos z. Understand, we are happy with this term because it is symmetric with respect to x, y, z. We are happy with this term because it is symmetric with respect to x, y, z. And therefore, one by one, we have to look at all the terms and figure out how we can make them symmetric with respect to x, y, z. What is the second multiplication? It is half. Sine 150 is half. That makes it minus r square cos x, cos y, sin z. Right? So now let us expand. So maybe we have to write these terms as it is, which are going to be constants. R square root 3r cos x, cos y, cos z. So we have achieved the symmetry. Now it is time to figure out with this. Now here we will use this identity again. X plus y is equal to 90 minus z. Now why that is the step at this stage is because right now this expression is dominated by x and y. Only z is present at couple of places. So we want to bring z also in this and reduce number of x and y's. That can be done by substituting 90 minus z over here, which makes it sin z, and 2 gets cancelled. So r square sin z inside bracket, you have expansion of cos x minus y, which is cos x cos y plus sin x sin y. Right? And then you have, is that done? Is it what I am already done? And there is a one more term, which is this, which is minus r square cos x cos y sin z. Okay. Now you will observe that once we expand this, we have one more symmetric term here, which we can write r square plus root 3 r square cos x cos y cos z. One more symmetric term, which is r square sin x sin y sin z, and you will observe that these two remaining terms cancel, and hence we achieve symmetry. This is symmetric with respect to x comma y comma z, implies ik square is equal to j I square is equal to kj square, implies triangle IJK is equilateral. Okay, I hope you have understood this particular solution, and this is a difficult problem. There is little adjustment of trigonometric ratios need to be done. Trigonometry makes it easy, otherwise it is a difficult problem. Once we solve this problem by complex numbers, I would try to put a solution on complex numbers, also using complex number also after we learn complex numbers. Thank you.